everyone, I'm Kate, and I'm super excited to be able to introduce you to our scientific computing lab. So, in this lab, you guys are going to get the opportunity to look at any data set of your choosing, and we will use some Python programming as well as some scientific computing skills to create some really cool visualizations of this data and to glean some awesome insights from it. So, we're going to keep it pretty high level today. So even if you have no experience coding or you have no idea what coding even is, that's totally fine. We're going to walk you through it, teach you some really awesome stuff, and we'll still be able to produce a really cool final product. So let's dive in. So before we get started, I want to take a moment to introduce myself and explain why I'm the one here talking to you guys today. So like I said, my name is Kate, and I just recently graduated from the University of Notre Dame with a degree in computer science from the College of Engineering. But if you would have told me when I was in high school that I just graduated with a degree in computer science, I probably would not have believed you at all because I had quite literally zero interest in computers. And honestly, I didn't even really know what computer science was because I just didn't think that I cared about it at all. But lucky for me, my freshman year of college, and this is a picture of me my freshman year when I was doing touchdown push-ups, which is a Notre Dame football tradition that's super fun. But this version of me had to take a computer engineering or an engineering computing course. And in that class, we learned to code. And so this was my first ever introduction to what code looked like or what it was. And I realized that it was super different from what I thought that it was. And it actually really aligned well with some of the things that I like to do and the kinds of projects that I liked working on, because I'm someone who really appreciates being able to think critically about a problem and then being able to kind of logically and sequentially work my way through it. And I realized that's a lot of what programming is. And so I thought coding was really fun. And I know that some of you guys are going to be asking yourselves, like, how is that possible? Because obviously, sometimes, not everybody thinks that coding is super fun, but you can kind of think about it like this. I think that coding is fun in the same way that maybe doing the Wordle or doing the New York Times mini crossword is fun, because it just gives you the opportunity to work on a challenge, to think through a problem critically, and then to have that satisfaction of fully working through something and getting that final product that you were looking for, whether it's the little tune that plays at the end of the mini crossword, or whether it's a program that runs exactly how you wanted it to and does what you were hoping. So trust me when I say that coding actually can be fun, despite what you may have heard or may have thought. And I actually found a way to make it fun for my job as well. So with my degree, I decided to work for Abercrombie and Fitch out of their corporate headquarters. And I was lucky enough to intern for them last summer, where I was a web development intern. So I got to work on their website, which was super cool. And this is a photo of me during my final intern presentation. And now I'm fortunate to be able to return to Abercrombie in their digital and technology department still for my full-time job post-grad. This is just one example of a way that computer science can be applied to something that I'm interested in, because I really like the retail space and learning about fashion things, and being able to work on both of those interests together has been super fun for me. So whatever it is that you're interested in, there's definitely a way that computer science can connect to that. And in this lab today, we're going to give you an opportunity to do that. So in today's lab, we are going to first learn about what coding is, as well as learn about coding libraries and see how they can really help us to write better and more efficient programs. And then we're going to download any data set of your choosing, like we talked about, and load that data set into a Google Colaboratory program where we're going to be able to code with Python to write a program that allows us to explore this data set, to learn more about it, and also to graph some pretty cool visualizations from that data. So scientific computing is really just using computers to solve problems in our world. So it really is all around us. And I'm sure that you guys can all think of different ways that scientific computing impacts your life and that it is all around you in the things that you're doing, because it's really never been easier to think of how computers are integrated into every single step of our days. But here are some examples of different ways that you might not have thought of scientific computing and how it can really improve our world. So one example of this that I think is super cool is that scientists are now collecting data about bees and their beehives using different sensors and different methods of data collection to gather all this information about what the bees are doing. And then we can write algorithms and programs that can track these bees' behavior. And so we're able to detect early signs of stressors on these hives so that we can help intervene if a bee population is about to be in danger or going downhill. And obviously, I'm sure you guys have heard about how important it is to save the bees and protect our pollinators. So this is a really valuable application of scientific computing. We can also apply similar methods to different forms of conservation with different animals and ecosystems more broadly. I also think another really cool application is using biometric sensors to get a better idea for athlete movements and figure out how we can help prevent injuries and improve athlete performance. Scientific computing is also a way that we can help develop safe space missions and help to explore outer space, which is also super cool. So now I want you guys to think, what are some topics that you are interested in? It doesn't have to be topics that are related to the previous slide. It doesn't have to be topics that are related to computers at all. Just try to come up with a few things when you think about your favorite things to think about, your favorite things to work on, or that you're interested in your free time. What comes to mind for you? So I hope that you guys all thought of a few examples of your favorite things to think about and work on. And I want you to keep those in the back of your mind as we work through this lab and actually start to talk about how we can accomplish all of these awesome things with scientific computing, like saving the bees or like going into outer space. So, as you may have guessed, the way that we actually get these things done is through coding. But of course, this leads us into another question. And that's kind of what engineering is all about, is just asking the next right question until we get to our final product. So in this case, the next question is, what do these programs that we need to write actually look like? And you may also be asking yourself, what even is code? And what does code look like? Well, the answer to that might be simpler than you think. And it's really just that coding is just giving a computer very specific and very ordered instructions, telling it what you want it to do. And so we do this through programming languages because despite what ChatGPT or other advanced AI models might make you think, computers actually cannot understand English or any written or spoken language, but they can understand programming languages. And so we have to write in one of these. And in this course, we're going to be using Python, which is a great beginner language. It's one of the most popular languages that anyone codes in the world. And so it's a really great choice to start out with. And then, of course, we also have to come up with a development environment. So as you can imagine, we can't just write this code anywhere. We can't write code in a Google Doc or type it into the Google search bar and expect that code to run. We need to run it in a development environment, which is a place that can actually execute the code. And so in this lab, we will use Google Colaboratory, which is a really cool development tool that allows you to save your programming files directly to your Google Drive. So it also has some other really cool beginner features that help us organize our code and work through it. But it also is nice because it probably will look kind of familiar to you if you have ever used Google Drive or Google Slides or anything like that. So next I want to watch this quick video to kind of reiterate the idea that coding is just giving the computer instructions, and also to allow you guys to look at some very basic code, because I think that even though coding is done in a different language, you might be surprised to find out that you can actually understand what's going on with code a little bit better than you may expect.
People that can code seem like they have superpowers, but what is code exactly? It's all around us, in our computers, phones, and in things like drones and self-driving cars. Movies and TV shows make it look like flying ones and zeros or weird green characters that look like rain. This comes from the early days of programming 30 or 40 years ago, when it was much more difficult and you really did have to know a lot about the internals of a computer. Today, it's not as complicated as it looks, and by the end of this video, you'll even know how to read some code. There are thousands of programming languages, but all of them are a way to tell the computer what to do. So let's say you're unlocking your phone with a numeric password. There are two possible outcomes here. Either you'll get the password right and your phone will unlock, or you'll get it wrong and your phone will ask you to try again. In code, this type of logic can be expressed in what's called an if statement, which, depending on the language, might look something like this. If you've never coded before, all of these weird characters might look strange to you, but let me show you how to read this. Computer code is usually interpreted one line at a time, so we can start at the top. First, there's the keyword if, and then inside of the parentheses, there's a condition it's testing. That condition is checked while the code is running, and it can be either true or false. We'll come back to that in a second. Here we have two words, input and password. These are what are called variables, and they store all types of information like numbers, words, a photo, and more. And you can name your variables whatever you want. I've named these two variables input and password because I want to compare what the user typed in, the input, to the password that's stored on the phone. The two equal signs means that we're comparing these two variables to see if they're the same. So we can read this as, if the input is equal to the stored password, then execute this next bit of code inside these two matching curly braces. And inside there's a line of code that will unlock the phone. But what if the input doesn't equal the password? Then the if statement will evaluate the false, and it will skip over the first set of curly braces and drop down to the else statement, and then execute whatever code is inside its curly braces. So, to summarize, we're saying if the user's input matches the stored password, unlock the phone. Otherwise, tell them to try again. And that's it. You just learned how to read a little bit of code. Of course, there are lots more coding concepts, but if statements like this pop up in almost every website and app in the world. Like I said before, that's just a small piece of a program. You can imagine how lots more if statements and other pieces of logic can be put together to make a full app. It's sort of like the rules of grammar and how words can be put together to form sentences, and sentences can make paragraphs, and so on. So, who writes code, and how do they do it? The people that write code go by many names. Sometimes they're called programmers or developers or coders, and they usually write code on a computer using special apps. Sometimes these apps are called text editors or IDEs, which means Integrated Development Environment. If the code is a simple website, usually it can just be uploaded straight from their computer to a web hosting service, and it'll work fine. If the code is an app that's meant to run on a Windows or Mac computer, or perhaps an iOS or Android device, then the code needs to be compiled. That means that the human readable code that we just looked at is converted into the simpler instructions that the computer will understand, like ones and zeros. This is way more complicated than what most people are able to read, which is why we have programming languages to make it simpler.
So now that we know a little bit more about coding in general from that awesome video, let's talk more about Python specifically. So as with any other programming language, each line of Python usually tells the computer to do something, as we've talked about a lot. So it might be performing a calculation, it might be saving a specific value to someplace in the computer's memory, or it might be printing a message to the computer's output, like this print statement on the screen prints hello world to the computer output. But there are also comments in code that don't do anything at all, and these are, like I said, just comments. They're simply there so that you can mark up your code, write notes to yourself, or write notes about what you're doing, and they do not execute anything. So these lines of code in Python always start with a hashtag or a pound sign, and it's important to remember that they're not actually going to execute anything. So let's try this out in our Google Colab notebook. I want everyone to follow the link on the screen if you want to follow along, or if you'd rather just watch for now and follow along later, you're welcome to do that as well. But if you are ready to follow along, go ahead and type in that link on your screen, and let's get started in our Colab notebook. All right, everyone, so welcome to your first Colab notebook. This is what you see when you open that link. And the first thing we're going to do when we get into this notebook, because this shouldn't be an editable file for you, we want everyone to make their own copy of this file that you guys can work with and edit by yourself. So go up here to this top corner and click the File button, and then scroll down to Save a Copy in Drive. Like I said, this might look similar to copying a Google Doc or something if you guys have done that. And after you save a copy to your drive, it should open in a new tab, and this is your own copy that you can edit. So the first thing you might want to do is rename the file up here. So I'm going to go ahead and call this Kate's SciComp Lab Practice. You guys can rename these to whatever you want, and these are going to save in your drive when you work on them. So as you can see, the first cell here is just a Colab text box. And so this cell kind of functions like a comment, but the difference is that these Colab text box These Colab text boxes are features of Colab and not features of Python. So if you are coding in a different development environment, you will not see these text boxes, even if you're coding in Python. So just keep that in mind, but they do kind of the same thing where they're just for commenting your code and organizing and leaving notes. So you can write whatever you want in these text boxes. And if you want to make another one, you can always just click that text button right there. So if you go ahead and run this cell by clicking the play button over here to the left, when you run that, you'll see that it's executing, and it finishes executing when you see that green check mark. And as you can see, absolutely nothing happened. And that's exactly what was supposed to happen. So if you guys want to write your own comment, you're welcome to do that by typing a hashtag and then typing absolutely anything you want, and nothing should happen. Now moving on to print statements. Print statements are supposed to do something, and it's a very simple line of code that just prints whatever you want to the output. So if we run this cell, as you can see, our output shows hello world. So why doesn't everyone try to write a print statement of their own and make sure that whatever you put in between the parentheses here, that you wrap it in quotation marks. So I'm just going to say, my name is Kate. And when I run this, as you can see, I get the exact output of both of my print statements. Moving along to operations, we can also store values in our code and do some simple math operations in code. And so this is a very common thing that you will see done in programs. And the very first thing we're doing here is creating a variable called xvar. So variables are just places that we can store values in our code's memory. And what we do here is we call the variable xvar. You can call this absolutely anything you want. It's totally up to you. And then we store the value of 5 in our variable xvar. And so we're going to print this value and see what that is. And then we create a new variable down here, which is called yvar. Again, these are just made up names. You can call it whatever you want. And we assign the value of xvar plus 2 to our y variable. And so when we print this out, as you can see, it'll first print the value of the x variable, and then it will print the value of the y variable. So what do you think is going to happen when we run this? Of course, we see 5, and then we see 5 plus 2 equals 7. So that's just a quick example as well of how we can store values in variables and perform operations on them. And then lastly, back to if statements. I know you guys saw an example of this in your video that you watched, but these are a common way to control the flow of code. So we can make our program do different things based on if certain conditions are met or not. So in this if statement, we see if 1 is greater than 2, print that 1 is greater than 2, or if not, then we're going to print this statement. So I'm sure you guys can all imagine what's going to print here. 1 is not greater than 2. So that's what we see as the output of this code. So now you've seen some cool examples about very simple ways of coding in Python. We have saved and reassigned some variables. We've done some arbitrary if statements. But what about when our code needs to get more complicated? Because obviously doing a if statement that says is 1 greater than 2 is not going to help us save the bees or do any of those things that we were talking about at the beginning. So we need to figure out how we can accomplish more complex things with our code. But does that mean that we need to write more complicated code and write super long programs? No, it actually doesn't mean that. And what we can do instead is use Python libraries. So Python libraries are essentially just a collection of code that has already been written and is now shared with us that we can all access. And this is something that even the best computer scientists will use libraries. It's not just like you're copying someone else's code. This is baked into Python, and it's best practice to use these things in your code. But you can think of a library just kind of like a toolbox. So think of if you were building something at your house, you wouldn't start by building the hammer and melting down the metal and creating the hammer shape and then attaching it to the handle. You wouldn't do any of that. You would just go to your toolbox and get the hammer out and use it for whatever it is that you need to do. And it's the same thing with the library. You don't need to start by writing all of the code that is going to do a pretty repeatable task. And so what you do is you just go into the library and you take that functionality that you're looking for out of the library, just like you would take the hammer out. You use it for what you need, and then you're done with it without having to start from scratch right there. So when we use libraries, we first have to import that library into our program. You can think of this kind of like moving the toolbox into the room that you are trying to accomplish your project in. So if you were building a bookshelf in the living room, but your toolbox was in the garage, then you're obviously not going to be able to grab the hammer out of it because it's all the way across the house. So we first need to go get that toolbox and put it in the room that we want to be working in. And that's exactly what we do when we import our library into our program. And when we do this, it's very simple. You just say import and then the library name. And you're also able here to assign it a nickname, which we call an alias. And so it's usually common in this step to kind of shorten down the library name, usually into like 2 letters. And these are pretty standardized kind of across the computer science and coding world, that most libraries will be shortened down to the same letters. And so you'll see that in our examples here as well. And then the next thing you do after this step is whenever you're writing your program, this next line of code doesn't have to come right under the import. It can go anywhere in your program. But whenever you're writing your code, you're going to call upon any functionality that you want out of that library by first calling upon the library's alias or its name if you didn't give it an alias, and then calling the specific function that you want out of it, and then passing in any parameters that that function needs. So we'll see what this looks like a little bit more here soon, but 2 libraries that we're going to be using in this lab are Pandas, which is a super helpful library that helps with loading in and working with data. So if you work with any data science Python programmer, they will definitely probably be using Pandas a lot. It's very common and very helpful. And then we'll also be using Plotly. We'll use like a little bit of a shortened version of it called Plotly Express. And Plotly is a library that helps us with graphing and visualization. So there's also some other common graphing libraries like Matplotlib that you might see, but in this lab, we're going to stick to Pandas and to Plotly. So let's take a moment to see what Plotly looks like. So just so we can kind of get a taste for how Plotly works, this is just about the tiniest Plotly example that you'll ever see. It's just 3 lines of code here. And so the first thing we do, like I said, is import our Plotly Express library. And we're going to import it under the alias px, which is really common. That's probably what you'll see whenever you use Plotly Express. And then what we're doing in this line is we're creating a scatter plot by, we're going to be plotting this X array and this Y array against each other with the title Tiny Plotly Example, and then showing that figure that we created. So when we run this code cell, we can see that our Tiny Plotly Example is printed here, and we have a data point at 1, 1, 2, 2, and 3, 3, just like we'd expect. So as you can see, this formatting looks a lot better thanks to Plotly. So you guys are familiar with simple scatter plots and with graphing in general, so it's pretty easy to understand how Plotly can help us with these things, especially after our example, but you probably have never heard of a data frame before. And that's totally fine because data frames are also really simple to understand, even though they are a new concept. So data frames are really just 2-dimensional tables of data that you can store in Python, and they're a super easy way to organize your data and store it into labeled rows and columns, and then also to be able to work with it and easily manipulate it given all the built-in functionality. And so this is what a data frame looks like, as you can see with the labels on top and the side labels telling you which entry you're looking at. And it just kind of helps you to be able to organize that data and work with it in a much easier way. And you'll see why that's important when we see how our data looks when it's raw, when it's not in a data frame. So now it's time to actually deal with our data. Data is really what makes our world go round, and it's the entire purpose of this lab, the entire purpose behind what we are coding for and what we're trying to do. And so we're going to use whatever data set that you guys choose to better understand that topic and to better understand the world around us, which is super exciting and definitely leaves us with a lot of opportunities. So with scientific computing, we can take data, which might originally just look like a bunch of random numbers that don't mean anything to us, and we can turn it into some real valuable insights in our lives. In this lab, we're mostly going to be working with CSV files to get our data. And this stands for comma-separated values files, which is pretty much exactly what it sounds like. It's a bunch of values that are all separated by commas in a file. And I want us to watch this quick video to help us visualize a little bit more what this looks like.
This is a CSV file. CSV is a file format used to store data. In a CSV file, data is represented in both rows and columns. The first row of the file contains the column names, and the rows below hold the actual data or records. Each record is a new row, with individual values separated by commas. That's why this format is called comma-separated values, or CSV. This CSV file contains my friends' names, ages, and information about where they were born, where they live now, and where they'd like to travel. Each friend has their own row in the file where information relating to them is stored. The position of the given piece of data tells us what the data means. For example, the value Seattle occurs twice in this file. In Alice's row, Seattle is the city she was born. But in Diana's row, Seattle is the city where she currently lives. The position of Seattle within the file tells us what it means. But just looking at our CSV data, it's not easy to see that Alice's Seattle corresponds to the born column and Diana's Seattle corresponds to the lives column. When a CSV is in its raw form like this, it's tough to quickly figure out which information goes with which column. Luckily, because CSV files are separated into rows and columns, they are often displayed as tables or spreadsheets. Now, it's much easier to determine at a glance that Charlie lives in Chicago, or that Diana wants to travel to Bali. Great. In practice, you can open a CSV file using a text editor. However, as we saw before, raw CSV is a little hard to read. Instead, Excel is often used to view and analyze CSVs. Excel automatically converts a CSV into a nicely formatted table. From there, you can use Excel's tools to summarize your data.
All right, so let's connect what we just learned about CSV files back to what we learned about data frames earlier. So I wrote up this, again, very tiny example of code where we import our pandas data frame, and then we're also importing another library here just to write up a very tiny CSV file. You guys don't need to worry about this library because you're not going to be writing your CSV file in your program. You're going to be importing your CSV file from the data that you download. So don't worry about this, but essentially what we're doing here is just saving this little mini CSV file, which is all comma separated values here, into our memory. And then we will read it into a data frame. So when we run the cell, let's see what comes out. So as you can see here, we get a data frame printed. And so when we do df head, that just prints the first few rows of our data frame since we stored our data frame in this df variable. And as you can see, this output here is much more nicely formatted, easier to work with. You can see that everything has been saved as its own data entry under labeled columns. And this is going to be a lot easier to work with in our code than this string that we uploaded into it. So this is a firsthand example that shows you guys how nice it is to be able to use data frames. And you can imagine that when our CSV files get a lot bigger, this gets even more helpful. Okay, so now that we've talked about the basics, we understand where our data is coming from and what it looks like, we understand a little bit about what Python basic coding does, it's time for the really fun part. So your task in this lab is going to be to use scientific computing principles to visualize your own data set as we've talked about. So this is the part that we've been working toward the entire lab where you finally get to pick your own data file and code with it. So in order to make this visualization, first we need to pick what data we're going to visualize. And we can do that by finding a data source online at one of these two websites. So we recommend looking at data.gov or at kaggle.com. If you open data.gov, this is the website that you'll be taken to. And the first thing that you want to do is scroll down here over to where it says formats in this sidebar and then click on CSV. And you can see there's almost 30,000 data sets about CSVs that you can select. Okay, so you can see when we search up weather, there's 272 data sets that are found for this category. So let's say we want to learn more about the meteorite landings. I guess that has something to do with weather. And when you click on this, you're going to want to go down to the downloadable resources here and download the comma separated values file. And you might have to click on a few other links to get to a link that looks like this, but you're going to want to download from something that has a CSV, and it's just going to look similarly formatted to this. So you can just click that download button and you'll have that ready to go. So when you pull up the Kaggle website, it's already going to be filtered by CSV for you, or you can filter it over here if you have anything else that you want to look for. And you guys are welcome to search for other topics that interest you. If you have anything that you thought of at the beginning that you're still keeping in the back of your mind, now would be the time to look for that. But I'm just going to go ahead and look at this airline flights data. And when we're working with Kaggle, the easiest way to download it, there's a couple different places where you can download this information. But the easiest place is going to be if you scroll down to this table here where it starts to show the CSV file and just click this download button right here. And then you'll have your data ready to go from Kaggle. So once you have your data from one of these websites and you've downloaded it all, let's go back into our Colab notebook, into a new Colab notebook actually, and start to really look at this data and see how we can load it into a file and work with it in a program. So now that we have our data set downloaded, We are back in our Colab notebook, and again, the first thing that we're going to want to do is make a copy of this file in the same exact way that we did before. So I renamed my file, and now we're just going to get right into it. So as you can see, this first text box tells us that the first thing we're going to do is upload our CSV file. So you can go ahead and run this. This is already written for you also. And when you need to do something in this file, there will be a comment that says to do. So make sure you read through all the comments, read through all the code, and make sure that you're knowing what part of this you need to change and update in order for it to work. So first, let's run this first cell, and it will come up with a file picker. Let's run this first cell, and it will come up with a file picker where we can select our CSV files that we just downloaded. So click this Choose Files button, and then I'm just going to search for my CSV, and I have a CSV file about food delivery time data. So now once that check mark is done, this code cell is has executed, and all of our data is uploaded into this Colab notebook. So the next thing we're going to do is load our data. So in this second area, the bottom line here is where we load our data from our CSV file into our data frame. So when we run this cell, we're going to need to change this area that says your file name into whatever you have named your CSV file, and make sure that it's the exact same name, because if you don't keep it as the exact same, then that file path is not going to work. So I'm just going to go ahead and copy and paste it directly to make sure that I don't mess anything up there. But if you are getting an error, make sure that you don't have any spaces added, make sure that you have the exact same capitalization and everything like that so that it works. And again, when we run that, we see a check mark right there showing that our data is properly loaded. So we obviously don't see where this data frame is, and so that's what our next cell is going to be, kind of about exploring this data and seeing what it looks like in our program. So what we're doing here, these are just some ways that you can set formatting options so that things don't wrap around. And then after that, we actually print the information that we have just formatted. So we're going to print the first few rows, just like we did in our example, by using df head. And then we'll print out all of our column names and then just some basic statistics about our columns. So when we run this cell, as you can see, we see the first few rows here. So these are the first few rows of our CSV file. Our first entry here, entry number 0, has an ID of 4607. This is the delivery person ID, and so on and so forth for all the different features of that entry. We can also see all of our column names. So these are the different features that our dataset offers and the different things that we can look into about this data. And make sure you look through all of these and kind of see what your options are. And then we just have some basic statistics about our data. So now that everyone has loaded their data into their Google Colab and you've gotten a chance to look at all the features that it contains, it's time to start thinking about what are 2 good features that we might want to compare or graph against each other so that we can create our first visualization. So we want to make sure that we pick 2 good columns that when compared, they might actually mean something and they might show us a correlation that we find interesting. And to do this, we can ask ourselves some questions about the data to consider what kind of relationships might exist between these columns or these features, and what might be interesting to look at when we plot it. So for example, for this food time delivery dataset, let's take a look at some of our column names and think about which of these columns would be good to compare. So we have delivery person ID here, and these are some examples of what these IDs look like. We have delivery person age. So let's ask ourselves, would it be a good plot if we plot the delivery person ID on the x-axis maybe and plot the delivery person age on the y-axis? Do you think that would yield good results? Probably not, because this delivery person ID seems kind of like an arbitrary list of numbers and letters, just like the ID here, that just identifies what delivery we're working with and what delivery person we're working with, but it doesn't necessarily give us valuable information, especially not when compared to their age. So why don't we try to think of something that would have a little bit more of a meaning? So looking through here, what if we take a look at the traffic level and see how that impacts the ratings that the delivery person receives? Maybe we think there might be a correlation between how much traffic that delivery person has to get through and what their recipient or their customer is rating them. So in order to create this chart, we're going to do this down here in step 4. Of course, we start by importing Plotly, and then the only thing you have to do here is replace your X column and your Y column and also rename your chart. So again, just as before, it's really important that you make sure that these X columns and Y columns are exactly copied and that we don't have any difference in capitalization or spacing or anything. So I'm going to go ahead and make delivery person ratings my Y column, just copy and paste those. And then I'm going to make traffic level my X column. And then I will create a new chart title and just call this traffic level versus ratings. And when we run this cell, and when that cell executes, we can see that we have a really cool chart here of the traffic level versus the delivery person ratings, as well as the distributions of all of these things. So we can also easily make different types of graphs in Plotly. So we're not confined necessarily to just that scatter plot that we made. And we can start thinking about, even with our scatter plot, do you think that a scatter plot was the best way to visualize showing the delivery person ratings with how they correlate to the level of traffic? When we look at this chart on the screen here, we can see that a scatter plot is best for comparing two numeric columns. So let's think about what we just graphed. We graphed one numeric column, which was the delivery person ratings. Obviously, this is a continuous numeric variable, but then we graphed that against the traffic level. And the traffic level was not a numeric variable. The traffic level came in categories. So looking at the screen here, what do you think might be a better way to graph these two variables against each other that can give us a better visual? So if you said box plot, that's what I was thinking too, because we're trying to compare the distributions of these ratings across the different groups, which are the different traffic levels. So let's go back and look at how we can update that visual by using a box plot instead of a scatter plot, and we'll see what we learn from it from there. So now that we know that we want to change this into a box plot and that a box plot might be a little bit of a better way to visualize this information, the only thing we need to do here is go up and change this scatter word into the word box, just like our previous slide told us. And then when we rerun this, we can see that we have a box plot here. And so now we have a little bit of an easier way to visualize this information more meaningfully. And as you can see, when we look at it, we see that the median for most of these different traffic levels is still going to be 4.7. So we see that a lot of customers are rating their delivery people pretty highly. They have pretty good ratings here on the 5-point scale, but we also see some outliers. And so these outliers are a little bit worse ratings. And where do we see the most of those? Well, we see more of them in the very high and in the high traffic level categories than we do in the low traffic, or in the very low. So as you can see, when we look at this, we start to realize that overall, customers are rating their delivery people pretty well, but when we do see outliers of poor ratings, we see them a lot more commonly when there's high or very high traffic. And that makes sense because it might be taking our delivery drivers a little bit longer to get there, and those customers might be a little bit less satisfied. There are also other fun ways to customize your plots in Plotly aside just the type of graph that we use. So you've actually already seen how you can customize your title and make that label of the graph different. You can also label the different axes in different ways, or you can color code the dots on your graphs by a different column category if you want to introduce a third column to compare against the other two. You can also change the color palette by using the template parameter. And we have the example here as Plotly Dark, but there are different color combinations that you can do as well. So if you're interested in that and you want to look into that, feel free to do a quick Google search to try out some different colors as well, and that might be fun. So why don't we go change our plot and customize it a little bit more and see what some of these things look like too. So if we want to change the color of this plot, all that we have to do is include that template parameter. So we'll just do this by typing a comma after our last parameter, and then we'll say template equals Plotly Dark. And as you can see, now we have a different color palette, and we have customized our plot a little bit further. All right, so after all of that, now it's time for your turn. So this is the super fun part where you get to use your data set that you found and that you've downloaded from one of our websites. And you guys are basically going to go through this exact same process with your own data. So feel free to follow these steps in the Colab notebook. If you need to, you can rewatch this video and see how we work through our code in this video. And you can also refer to your student worksheet, which will help you work through all the different steps that you need to take to create your visualizations as well. So with your final one, you're going to, like I said, follow along the code given to you and create that initial visual and that initial graph, and then create your own graph from scratch that tries out a different graphing technique than a scatter plot and also incorporates a title and at least one more customizable element that you have created to make your graph the best that it can be. And when you're done making your graph, make sure that you take a look at it and really analyze what it means and how your results might relate to the real world, who might care about them, and why are they interesting, just like we did for that box plot. So as you work through this lab, if you enjoy it, there are a lot of other wonderful opportunities within Engineering Tomorrow that you can explore if you like this field and if you're interested in these topics. So if you're curious about looking more into computer science principles as a class, we have Engineering Tomorrow labs covering software engineering, machine learning, cybersecurity, robotics, and even more. And we also have an Engineering Tomorrow scientific computing full course that's designed to teach you how to code for scientific computing skills through a series of different interactive modules and assignments, and also a really cool final project at the end. So we'll have ET staff guide you through this course and give you feedback throughout it and help you produce that final product that will really teach you a lot about computer science, a lot about how to code, and it will also be a big resume booster for you as well if you are interested in putting that and advertising yourself for any future opportunities. That's a really great opportunity for that as well. So it's definitely a lot of fun, and it doesn't require any prior knowledge of coding to register for if you're interested in it. It's also free of cost to all students or anyone who signs up. So if that sounds like something that you would like to look further into and that you're interested in being involved in, please have your teacher reach out to our Engineering Tomorrow staff, and we can give you more information about when that course is next being run and how you can get registered for it. Thanks so much for all your participation in this lab, and we're super excited to see what you guys all come up with. Good luck with all your scientific computing.